Good morning, good day, good evening, good night, wherever and whenever you're listening to this. Welcome to the Bitaxe Townhall. I'm One Clue, your host, and today with me do we have Schnitzel on the stage. Hey Schnitzel, how are you?
Hey, one clue. Hello, I'm good. Thanks for having me.
It's awesome to finally have you here. For everybody who's tuning in just recently, we are writing the Town Hall number 60. And if you're looking for any further information about all things that are going on in the open source mining ecosystem, check out osmu.xyz or osmu.wiki. So, Schnitzel, tell us a little bit about yourself. Who are you and what are you doing?
All right, yeah, happy to. Yeah, so hey, my name is Schnitzel, or my real name is Michael. I'm originally from Switzerland. I grew up there and I live around 10-ish years. I live in the US now. Yeah, my background is software engineering, so that's what I do in my day job. I run a company that does some software stuff, and but hardware has always fascinated me and interest, right? Because if you sit in front of the computer all day and write software, you never actually see your stuff that you're building, and so hardware has always been something that I was very interested in, but I just never actually did it as a job or something. And so when I moved to the US, one of the rather interesting things in the US is that you are allowed to do a lot of changes to your house legally, right? You don't need to actually hire inspectors or things like that, at least where I live in Virginia. But also, you actually get access to a lot of materials that at least when I lived in Switzerland or in Europe, it was actually quite hard to get access to some of the stuff. So I've always been interested in Bitcoin. Actually started quite early, but mining wasn't really something, at least in the beginning, that I was into. And then around 2020, when we all had way too much time, I bought some ASICs and just played with it and realized, hey, they are pretty loud but they're also getting really warm. So since then I've been looking into all kind of different ideas on how to reuse the heat, from heating my garage to heating an airstream trailer to heating a house, a hot tub, etc., etc. And so if you actually look at my Twitter/X profile, you will see all kind of videos there and pictures of all the different projects that I've been building. So
Oh, please don't die.
I'm trying not to. Sorry. Yeah. So I've always done these things, and it always culminated down to actually that whenever I use these miners, right, I've used from S9 to S19s, to S21s to M64s. Every time the problem is how to actually control them, because you can't really install, or this is changing now, but at least when I worked on it, you couldn't really install like your own software on these control boards. And so I've always had to like use a Raspberry Pi or some kind of external system to control these miners. And when the 256 Foundation started, and Eco Alchemist, one of the founders of it, he described this idea of this Libreboard, that is an open source control board. I really saw this like, this is exactly what I've been waiting for the whole time. And so, yeah, I applied for it and I got the grant. That's what I've been working on in the last month, is building the Libreboard.
All right, so this is kind of an interesting thing. So you originally been from Switzerland, moving over to the US just to do whatever you want, probably, especially in your household, as it seems. But now diving into the scene of open source mining, or at least changing the mining back into something that is more open source than it has been previously. So you talked about the Libreboard. What what exactly is it?
So the Libreboard is basically a solution if you want to use your miners for more than just 24/7 mining. For anybody that has seen a bigger miner, so we're not talking about a Bitaxe, but we talk about an S19 or something, they do have a control board that has usually an Ethernet port, and has connections to the hash boards. So the hash boards actually don't talk directly with the pools or with the internet. And this is all done through the control board. And the control board, talking to the pools, receives work and then converts that into work that is sent to the hash boards. The problem is that these control boards, they're not very powerful. So they're usually 400 to 500 megahertz of CPU power and have a couple of megabytes of RAM. So if you want to run anything complex on them, let's say a Bitcoin node, or like a little bit more complex control systems, let's say with Home Assistant or any other, it's going to get very hard. So that's one problem, is that hardware is not very powerful. The other problem is that the firmware on it is not open source. So it's not really accessible. Now, there have been, and we can maybe talk about this a bit more, with Mujina, we have done quite a lot of work, and actually it looks very interesting, but still, even if we can install stuff, you cannot really do it. So what the Libreboard is, it's basically a replacement for such a control board. So its main job is to talk to the pool and send jobs to these hash boards that are connected to the Libreboard. But we're building it compatible with these Raspberry Pi compute modules. So if you've never seen this, maybe Google Raspberry Pi compute module. It's basically a full-fledged Raspberry Pi, but with no input-output ports at all. It just has at the bottom, it has a 200-pin headers that you can basically use these control boards, and you can plug them on top of another PCB, right? So you plug one PCB into the other PCB. And the lower PCB, which is what the Libreboard is, it uses the Raspberry Pi for all its CPU and memory and all that stuff. But you can make your own input-output ports, right? So it's like an expansion board for a Raspberry Pi. And for that, I was able to build a purposely built control board for mining purposes. So we can maybe go through each of individual ports, but it's with mining in mind. So we have things like fan controls and things like that on it. But what is also really cool, there are a lot of different compute modules out there from Raspberry Pi. So the lowest one is basically, it just has one or two CPUs and like 1 gigabyte of RAM. And then there's a super powerful one that goes up to a multi-core and has 16 gigabytes of RAM. Plus, there is also a slew of third-party companies that also built the same hardware interface. So there's, for example, a RISC-V version of it
From
and things like
Raxa,
that. And what
right?
that allows... Say again?
I said from the company Raxa or Retzo. I don't know how to pronounce them.
Yeah, there's all kind of different. So there's like a company called Orange Pi. I think
Yeah.
they're ARM-based. There's the RISC-V ones, etc., etc. And what is really cool, like that actually allows people to decide how powerful do they need their control board to be. So if you just want it to mine in a miner, let's say that runs 24/7, and let's say you just need to expose an API, that's fine. You can use one of the lower ones, because Mujina, the firmware that runs on this control board, is not very power hungry. But and that's when we go to the Dumax, right? You can actually fully install Bitcoin nodes, etc. So that allows us to basically build the miners that we really needed, right? So if you want to build a super powerful with a Bitcoin full node and maybe even install Home Assistant or something else, you can do it all on the control board, and you don't have to do anymore as we had to do in the past or still today. You basically have the miner with the control board, and then you have a Raspberry Pi, and you need to talk through an API, and the APIs of the firmwares are bad, and like there's all these problems, and then like how do you talk through them through Wi-Fi or Ethernet, and like all that stuff goes away, because you will basically have one single control board. You can connect as many hash ports as you want to it, and you can connect all your temperature sensors and fans and pump sensors and all the stuff. You can all attach to it, and that's going to make so many things so much easier to build. Basically purposely build Bitcoin mining for heating, heat reuse, whatever you want to build with it.
Let's stop there on the part of connecting things to it for just a second. So you just said we could technically just connect as many hash boards as we want to like. Well, one thing that we do know is these hash boards produced by these bigger companies like MicroBT, Bitmain, Avalon, Canon, and so on, they do have like purposely used connectors. Does the Libreboard also use them, and can I extend them, or how can I technically hook up 20 hashboards to one Libreboard?
Yes, very good question. So together with Scott, right? Scott built the Ember ones, which is the 256 Foundation hashboard. With right now we have 12 mining chips on it. Right now we use the S19J Pros, but there will be other ones with other Bitmain. I know he's also working on the Intel chips and other stuff. But we agreed that we're going to use USB-C as the communication protocol for between the Libreboard and the Ember one. So, and because it's USB, you can basically just add USB hubs. So think about this, right? You have the Libreboard by default has 4 USB-C ports for the hash ports. But if you want to add a fifth or a sixth one, all you do is you take a USB hub, you plug it in between, and you connect it. And that's one of the main philosophies that we are doing with the Libreboard is like, why do we need to reinvent the wheel if it already exists, right? Hot, pluggable, expandable systems we already have. It's called USB. So we're just reusing that. Now, as you're mentioning, though, correct, some of the hashboard, basically every hashboard that you can buy until we're going to release ours, has its own proprietary connector. However, we've already reverse engineered the complete communication between the control boards and the hash boards because we had to do this, right? In order to build the Bitaxe, we actually had to figure out how to reinverse, how to talk to these chips. That also means how do we talk to a whole hash board? And so there is a project by Scott, it's called the Edit Board or the Bitcrane. And what they do, basically, they convert USB back to the hashboard communication protocol. The Bitcrane connects 3 hash ports. So you have a little PCB. It's actually the same size as the control board that is in the miner. And it has USB on one side and just 3 hashboard connectors, like these ribbon style cables, connectors on the other side. And the edit board is just one single one. So it has one USB and one hashboard connector. And with that and USB hubs, yes, you could basically connect 20 hashboards to a single Libreboard. And what is also really cool, right? You can actually mix and match. That's something that is not possible. Current firmware, even some of the open source firmware or some of the third-party firmware like LuxOS or Brains, they actually refuse mix and matching. But because we control the firmware and we control the hardware, you can actually connect S19s, S21s, S23s all together. It's probably even going to be possible to mix different hardware providers. And I think we can talk about this a bit more, but I think that actually opens up an even wider possibility that you, for example, have like high performance and high efficiency boards at the same time inside the miner. And depending on how much energy you have available, let's say through solar panels, you could run different boards. Like this allows massive new things that, I mean, right now we can just dream of.
Well, the current thing is, or I'd say the current problem that will arise with exactly that is that you need to control way, way more things than we used to do before. I mean, as you pointed out, these manufacturers that are currently producing third-party control boards, they usually refuse to connect to like different sorts of miners or to mix and match them. The only company that I do know of that does a control board that basically talks to like more than one hashboard type is um this cube thingy. The logo is a cube. I'm thinking about it. I'm
Is it Epic?
Epic, yes. They do at least Antminer and MicroBT. I'm not sure if they also have something for Canon chips, but that comparing that to like the different third-party control boards that we do have, it is not really something that is broadly available. And when we start mixing things, we do know that these hashboards run, for example, on different voltages. So just the power stage itself will be way more complex if you want to do something like that. But on the other hand, as you said, like opening up new possibilities is going to be insane. So how exactly are you planning on something like integrating power control into the Libreboard and the Mujina firmware.
Yeah, so if you say power control, you mean of the miners itself, like of the
Yes.
hash boards? Yes. So that's actually one of the things that will happen on Mujina itself. But I'm in constant contact with Ryan, the maintainer of Mujina or the lead developer. And basically, the idea is that as you have with Brains, LuxOS, Epic, Vanish, like all these different firmware providers or third-party firmwares, you will be able to do some kind of tuning, where right the stock firmware basically runs all the chips on the same voltage and speed or the megahertz. However, if you each of these chips, they have their own optimized level where they provide the best performance. And that's what tuning is. So you basically go through a range of each of the chip and you test where each of the chip provides the best output. And that's the tuning what some of these firmware, right? That's why these third-party firmware claim that they can do 5-10% more hash rate. That's basically what they're doing. And the very same thing we can also build in Mujina. But not only that, I actually believe we're going to be able to build stuff in Mujina that is completely unthinkable right now. For example, most of the firmware, if you want to like reduce the watt output, right? You can some of these firmwares you can say, okay, I want you to not mine with your regular 3,000 watts. I want to do with 2,000 watts. A lot of times, what happens is that the whole miner stops and starts to hash from like a zero back up. But like one of the things that I'm saying is like you have already 3 hash boards. Just disable one of them if you want to go to 2,000 watts. But none of these firmware providers is really interested in any of this. And so, like I have a lot of people that ask me like, how can we do like solar panel things like that? My problem is that the miners restart all the time. Whenever I tell them just a little change of wattage. And I think that's specifically in power management, there's going to be so many more things that we're going to be able to do in the future. Plus, obviously, also with the rise of AI, it's going to be a lot easier to do customized things, right? So if anybody has one specific case that nobody else has, you will just be able to go to an AI, point it to Mujina, point it to Libreboard, and saying, hey, I have this specific use case. Can you come up with a power curve or like a ramp up or ramp down or whatever you exactly want to do? And the AI will be able to build that into your specific for that specific use case. So I think specifically around power things, I don't even think we even understand where the ceiling is because there's just going to be so much possible.
This just sounds amazing. Just for your reference, I posted in the chat the link for the Libreboard GitHub repository as well as a picture. Should we take a
Yes.
closer look on the picture of the Libreboard itself and
Yes.
just quickly go
Yeah,
over
let's
what
do
we
that.
do see on it?
Yeah, so let's start on the top left. As I mentioned, we have 4 USB-Cs. So these are USB 2.0, right? Because we don't need USB 3 to talk to these hash boards. We just need regular USB. And so by default, you can connect 4 hash boards like the Ember One, but as mentioned with other systems like the Bitcrane or Edit board, you can also connect other hash boards or like regular hash boards to it. Right next to it, we have this 12 to 24 volt DC. So that's another important thing. Together with Scott, we agreed that we want to build the first hardware. So that means the Libreboard and the Ember One. We want to be able to have an input range. And so, right, the regular hash boards for like an S19J Pro, they need one specific voltage. And Scott decided that he wants to do his hash board, the Ember One, is to have a range of 12 to 24. He actually went down to 12 to 18 because we realized not many people need 24 volts anyway. And it's actually quite hard to find some of these voltage regulators. But yeah, so you basically have a range. So that means that you could run this on a car battery, or you can run this directly from a solar panel that has this 12 to 18 volts because it has its own voltage regulator on it. The Libreboard itself needs actually most of it is 5 volts because the Raspberry Pi needs 5 volts and things like that. So there is a voltage regulator in the top left, that converts the 12 to 24 volts to 5 volts. But it also needs 12 volts because you need to be able to connect fans to it. So there's actually a second voltage regulator that converts the 12 to 24 volts, but down to 12. And then on the top right, you see this module 1. So this is these are the 200 pin headers that I talked about, where you actually click in your Raspberry Pi, the CM5 or the compute module 5 that you can connect to it. On the top right, some of these compute modules have fan connectors, so you can connect your fan to the compute module. And then if we continue, let's go clockwise. So if we go to the right, there's this white M2 connector that we see there. That's actually an M2 slot, and you can connect all kind of things in there. The assumption is that people want to connect an NVMe SSD connect to it, for example, to run a Bitcoin full node. But you can connect anything that runs M2, right? So there are a lot of other M2 things, mostly storage, but there's other control or things you can connect.
Let's quickly
At the
stop
bottom,
there with the M2
yeah,
key that we do see. So we've taken a look on different comparison connector boards for compute modules. There's one thing that we do know, that the compute module 4, for example, does not have any PCIe lanes, while the compute module 5 does have it. How do you gonna handle M2 keys, especially for SSDs, if you're using a compute module 4 and not a 5?
yes. So the idea that the Libreboard is based or is built for the compute module 5. My understanding is if you connect the compute module 4, it should work. However, yes, the M2 doesn't completely work, or it has some PCI, but I'm not sure if it has full support for all of it. So that's actually some of the things that I'm currently doing, is validating and testing all of the things. So yeah, but it is built with the CM5 in mind, and that's what I'm currently testing with. Yeah, so if we continue at the bottom right, we have the USB 3. You see there is a connector there. So that's actually to connect any types of USB 3 things. So the Raspberry Pi CM5 has two full USB 3 lanes, and one of them is used for the USB 2 on the top left. And on the bottom right, you actually have USB 3 that allows you to connect external SSDs, displays, whatever you want to connect to it. So it's a full USB 3 connector. Then we have Ethernet, obviously, right? That's standard or what people need. Oh, what I actually forgot. The Raspberry Pi itself, the CM5, has Bluetooth and Wi-Fi on it. So this will be fully Wi-Fi capable. We don't have to add any antennas because that's already on the CM5 itself. So in terms of connectivity, you have Ethernet, as we see, but also Bluetooth and Wi-Fi. Then there's an HDMI connector, so you can connect any external displays. Then there's this CAM display port. So that's a Raspberry Pi own connector that I think the protocol is called MIPI. And it allows you to connect the display with touchscreen, which is really cool, or a camera. So, like, if you want to monitor your miners, I've heard people that want to do like fire or smoke detection. You can directly connect the camera, and that's it. Then there's a little battery on the very bottom left. That is to run the real-time clock. So the CM5 has a real-time clock, and especially if you have cases where you plug out the compute module for a very long time, and you maybe don't really have good Ethernet or networking time, you can put a little battery in there to keep the clock running. It's not necessary though. Then just above the CAM and DisplayPort, the HDMI, we see that 12-volt fans that I talked about. So the control board comes with 4 12-volt fan connectors with full RPM control. So each of them, you have 4 different fans you can connect. So whatever you want to do, the assumption again is that each of the M1s has 1 fan, so you can connect the fans there. But again, you could connect whatever you want to it. Then we see this quick. We don't see the actual header, but quick is basically a new, really cool idea that comes from the Arduino world, which is basically an I2C bus But Quick specifically defines that it's all daisy chainable. And Quick means that you can connect little displays, temperature sensors, motor controllers, LEDs, brightness sensors, gyroscopes, accelerators, buttons. So you basically just connect them into the Quick, and every Quick board, as I mentioned, is daisy chainable, so you can connect multiple sensors to there. And that's really the main connector that I think people will then tell the control board about its environment, right? I have a lot of people that telling me, oh, I want to do like a room sensor, or I have like an immersion system and I need to have a pump speed sensor and things like that. And they all already exist, right? Again, it's this philosophy of saying, let's reuse existing systems. People have solved these problems already out there. So that's why we're using Quick to connect to all of this. And that's really what I'm excited about, because you can basically connect whatever you want. Then on the left, we have an SD card. There is a little bit of specialty. So some of the compute modules, they have storage themselves, or eMMC storage. Then the SD card actually doesn't work. Or some of the compute modules, they called light modules. They don't actually have storage on them. So then you use like a regular SD card. Like if you have used Raspberry Pis, a regular Raspberry Pi, you know about this SD card stuff that you can flash. But the suggestion actually is to get a compute module without an SD card, because specifically if you run, like as maybe some people are aware, that SD cards are actually not very good for long-term usage, and so that's there. But we added it if somebody wants to try with a light module. And then the other interesting thing is there's a Raspberry Pi hat. So as a regular Raspberry Pi, you can connect any hat to it. So we spend a lot of time making sure that every single of the Raspberry Pi connectors that is on a regular Raspberry Pi is also on the Libreboard. And with the hats, you basically will find hundreds, I think we're up to 1,000 different hats that you can find, from audio controllers to motor controllers to like even pyrotechnic things to displays to AI things, whatever. So whatever you think, you find a hat for Raspberry Pi, you can put it onto the Libreboard and you can build whatever you like. And I think that's like the philosophy of let's reuse existing stuff, let's make it expandable, because everybody, right, has different needs around what they maybe need for these for these Libreboards or for these control boards. Then on the left, we have a power button and a flash mode. That's basically to flash the Raspberry Pi itself. And then we have a USB 2. That one is exclusively to flash. So if you want to install a firmware on the operating system on top of the CM5, you need a USB 2, and that's how you do that. And then on the very top left, we have a power button and a status button. These are standard with the CM5. And then we have a status. It's not propagated there, but there's an RGB LED that can be used to show any kind of status. As we know on regular miners, right? There's this red LED that nobody understands what it means. We said let's do an RGB so that we can actually show like different colors. So red blinking or green when everything is fine, etc. And yeah, so that's the whole thing. As you can see, there's a lot on it. And what the idea of this is, right, that while I'm creating the control board, I'm basically trying to put as much as I can onto this board. I can imagine that maybe somebody says, well, I don't need the M2, or I don't need HDMI, or whatever. I don't need the Raspberry Pi hat. And the idea is really that people can build these themselves and can also just remove stuff. It's a lot harder to add new things to an existing PCB than removing. And so what I'm really trying to do is optimize the space as possible. Obviously, that makes it also a bit expensive because you need all these components and stuff like that. But that's basically the idea behind it, is that the manufacturers of these, right, like with the Bitaxe, I'm actually not going to sell or manufacture these. This is an open source project. So the idea is that actual people with pick and place machines and have the capability to manufacture them will take the open source code and manufacture them. And there might be people, or there might be companies that saying, okay, they maybe make different versions of the Libreboard. Who knows? Maybe there's going to be a Libreboard Lite and a Max with different components on it, just for having different prices. And obviously, because it's open source, anybody can take this and also add additional things. So I've already heard people saying like, but I want 10 USB-Cs by default. And that's totally possible. You can just take it and modify whatever you want. So yeah, that's it.
That's quite a lot of information to digest here, and I really love how you put in like every single detail that you thought might be something worth to put onto a control board to make it fully something that can be in control of the user. So the thing that probably the most people are currently interested in is, do you have one, and what are you currently doing with it? And just for the sake of putting out that question, I'm gonna post another picture in the chat for the people to look at, and maybe you will tell us a little bit about what you are trying to do with that.
Yes. So the current status is that we are at revision number 2. So the picture that you're seeing is actually revision number 1, because when we build revision number 1 during the production of it, we realized that there were some issues. Like usually with hardware, it's hard. That's why the name of the word is in there. And so I actually worked with Eco Alchemist. So he has an pick and place machine. So I created, I think we built 5 boards. We actually created from JLC PCB, and then he put 2, or he started to assemble 2 of them. However, we realized that there is an issue with I think one of the resistors was wrong. And so we fixed that. So that's revision 2. If you look on the GitHub repository, there is a revision 2. However, I now received one, and that's where we're getting to the DoMax. I started to build it together, right? Because that's the thing. You need to test the hardware. You can do a lot of testing online, and KiCad obviously helps you with testing. You can also help with the help of AI. You can actually test some of the things, but nothing beats actually installing it. So when I received the boards, I basically needed to create a test environment. And the test environment is basically buying all kind of different connectors, right? And HDMI display, so a couple of quicks, a fan, all these different things. And I started to build, or I started to connect all this different stuff together. And actually, unfortunately, I realized that something is wrong with the USB controller. So on the very top left, this big empty space that we see with the ground plane there, that's the USB controller. And something is off with the USB-Cs. That's actually very weird. So the USB-C, they work initially, and then over a couple of hours, they die. We saw this issue on both of the boards that currently exist. So there's 2 Libreboards in the world right now. Both of them, the USB died over time. The bottom right one, the USB 3, still works. So so that's why we're doing. But yes, getting to the DoMax. So I built all this stuff together. Like I connected a display, a fan, and things like that. And I actually use a Bitaxe Raw as the hash board, because I don't have an Ember 1. But a Bitaxe Raw you can connect via USB, also to a computer, and in this case, the Libreboard. And so I'm using a Bitaxe Raw as the hash board. And I built this all together. I shared a couple of pictures of this with team members of the 256. And then actually, Eco Alchemist had this idea saying, hey, there is the BitCon Las Vegas is coming up. So that was in like March this year. And he was like, couldn't we like take this with you? Because we knew we're gonna be on stage, and we're gonna have like the Mara Foundation has their contest to win this grant and like all this stuff. And I was like, well, technically, yes, like all these things, right? I installed the Bitcoin full node. I run Hydra pool on it for my own pool, and I have a display and I have a fan. And so, yeah, in a couple of days, I basically added a battery to it because, again, right, it has a variable input range. So I just use a LiPo. I think it's an 5S. Let me actually check. Actually, not sure if it's 5 or 4S. Doesn't matter. But it's a correct input range. Yeah, so I added the battery. So that's what you see on the picture on the top right. I have a fan. There's the Bitaxe Raw in there. There's an SSD on it. There's a couple of quick connectors. There's the display that points to the down, but it has touchscreen. And with some help of AI, I also built the whole case. So I have a 3D printer at home. And so, yeah, maybe one clue you can post the other picture of actually it together on the table. So that's what we ended up. It's basically a full open source hardware and software Bitcoin miner completely ran by a battery. I'm not sure if this ever existed, or at least it hasn't existed for a long time, that you have a completely battery powered, fully open source Bitcoin hardware and software. The only piece that is not open source is basically the ASIC chip itself. But everything around it, the Bitaxe, etc., is all everything open source. And we call it DoomX because there is actually a little display on the side. Maybe I can find a short picture. It's probably on my Twitter account, but there is a little display, a little OLED display that is like I think it's 300 by 200 pixels.
I just
And
posted the
I
second
looked at
picture.
perfect, yes, but there you don't see the don't see the little display.
Oh yeah,
I'll
no.
find one. Anyways, right, so there's this little OLED display on it, and I was like, what? Whenever you see these little OLED displays, there is this question like, does it run Doom? You've maybe seen like people using these OLED displays on like pregnancy tests or things to play Doom on it, and so I was like, hey, can this run Doom? And again, with AI, right? This is all open source. It's Linux running. And I literally just went to Cloud Code and said, hey, here is this little display. It's connected through Quick. Can you run Doom on it? And yeah, it runs Doom on it. And so that's how the name, the DoomX, came about, because it's basically a Bitaxe that runs Doom. And funny enough, it seems now to become actually a standard. I just saw other people using the Brains BM101, like their own desktop miner, and they're starting to install Doom there as well. So I think we started a little bit of a trend that like, can you run Doom on it on Bitcoin mining is now going to be a thing for the future, and that's why it's called the DoomX.
This is, I'm still trying to comprehend everything together and just try to understand how crazy this is potentially going to be, especially for the market of opening up the possibilities for the users of ASIC mining machines to actually do whatever they want with it. And I mean, one thing that might be interesting for a couple of people is running your own node on your miner.
Mm-hmm.
And if we think about it, usually the most first thing I'd say that comes to mind is like, well, you only want to do that if you use Stratum V2. Is there already something like Stratum V2 implemented in Mujina? Do you want to dive a little bit into Mujina, what it currently is capable of and what not, and what will come in the future? Or do you say, well, this is more a topic for Ryan?
No. I mean, you should definitely have Ryan on, and he can tell you a lot more about it. But I am happy to give you a little bit of an overview. So Mujina is basically the open source firmware that by the 256 Foundation. The idea is that Mujina will power all mining things for the future. Right? We have not had an open source firmware for a very long time. Brains OS used to be open source. However, as it goes, that there were some people that did not respect the license correctly and took some of the Brains OS stuff, created their own firmware, and didn't open source themselves. So unfortunately, Brains removed or basically stopped open sourcing their firmware. And so yeah, we did not have any open source firmware, and Mujina is basically the answer. But we also want to do it a lot better. So what this means is, yes, it's going to support all kind of different hash boards, right? It's not just for Bitmain or WhatsMiner. It should support anything. And because it's open source, you can basically do whatever you want with it. So you need to look at Mujina like a little bit like the Linux kernel. Right, the Linux kernel itself, the Linux team that builds the kernel, most people actually don't run the Linux raw kernel. So what a lot of people are using is they're using some kind of distribution, right? There's Debian, there's Ubuntu, there's all kind of other ones. And so we're thinking about this the same, that Mujina itself is just going to be the kernel. You can run Mujina if you want. However, an actual installation will probably run Mujina plus additional software on top. Like, for example, a Linux desktop environment and things like that. In Mujina, it's maybe like a system that talks to that has a little display or a UI or things like that. And so, but Mujina is extremely pluggable, meaning you can install additional drivers for different hashboards. So today, Mujina is built with the Bitaxe raw in mind, because that was the first basically hashboard that was existing. So it can mine to a Bitaxe raw. It also, what is really cool, it actually has a CPU miner in it, which obviously is not useful because you will get a couple of mega hashes out, but it allows you to test a lot. Right? So if you just want to build against Mujina, you can literally just run Mujina on your own computer, and you can tell it CPU mining, and the whole APIs and all that stuff will fully work because you can just CPU mine. So that's what I actually do a lot when I work with Mujina. I actually don't run Mujina on an actual miner. I just run it on my own Mac and tell it to CPU mine, and then I can interact it with the API and things, all that. But what we've seen, and it has not landed yet in Mujina itself, but Scott and I and other people have been using. Basically, we're connecting what the Bitaxe team has figured out, right? How to talk to these hashboards, or how to talk to the chips. So what we've basically done is we now added support for S19J Pros. I just added support for an S19K Pro. I know there's some people that build an S21 support, and as Scott is building, like he's playing with the Intel chips and things like that, and that's really all possible because of AI and because Mujina is open source. So what I'm literally doing, right, for the S19K, what I'm actually telling it to do, my AI is I install LuxOS on an existing control board, and I let it sniff the whole communication between LuxOS and the hashboard. Because it's Linux, you can sniff the I2C communication. And so this is a massive dump of like 60 or 70 megabytes of just communication protocol between LuxOS and the S19K hashboards. And then I tell the AI, can you implement this in Mujina? So it goes off and it analyzes the dump and it sees how it communicates and all the special things. And literally like a half an hour later, it has a Mujina version with S19K support. And then I install Mujina on the control board and let it run. And usually, I mean, in that specific case, it maybe took like 3 or 4 additional fixes. But that's how easy it is basically to add new hashboard support. So again, this is super early and we haven't built everything and we need to document a lot of this stuff. But what I really predict is that as soon as we have done all of that, and I know Ryan is working on this, it's basically going to be extremely simple for anybody that has any miner out there. So right, S9s, S19s, S21s, S23s, all these different kinds of Hydro versions, hopefully also the Watts miners, that you basically can point your AI to the existing miner. It will figure out how the communication protocol works, and it will build it into Mujina, and bam, half an hour later, you have Mujina mining on a completely new miner that has never seen before. And so that's really the power of Mujina, because you don't have to worry about all this stuff of like, how do I talk to miners and how do I talk to the pool and Stratum and all that stuff. That's all there, right? All we have to build now is the drivers for the individual hashboards. And I think, like I said, this is going to go so fast that we're going to basically I really think that Mujina is going to run on every Bitcoin miner, I would say maybe in the next 4 or 5 years. Because just it does not make sense anymore to run stock firmware, which is horrible. It also has security issues, or some of these some of these third-party firmware, because it's not open source. And if anybody wants to build something like we talked about, power control or whatever, you can just talk to your AIs and to your Mujina, and it will be able to build it. So I'm extremely excited what is going to happen with Mujina, obviously connected with the Libreboard in like big house systems and things like that. But yeah, it's going to be extremely exciting at the next couple of months.
All of this just sounds amazing and fantastic, and especially as you pointed out, the easiness of implementing new features, especially these days, is just not existent. Like there's no hard part about it any longer if you at least know a couple of things that you need to do. So if you do take a look in the future, and you briefly pointed out that your expectation is in probably the next 5 years, we will see way more usage of Mujina and the Libreboard, or maybe both together. What else are you expecting for the future? What is the future outlook for the Libreboard from your perspective? So maybe what are you missing?
Yeah. That's a good question, right? Like the main reason that I'm building the Libreboard is because every time that I try to use a Bitcoin miner in any heating solution, right? That can be for a hot tub, that can be for a house, pools or driveways, whatever. Think about for any heat reuse capability, I basically somehow Frankenstein had to use an existing miner and then add a Raspberry Pi to it and all that stuff. And so I really think, and I know there's people already working on this, that we will have some kind of heat reuse systems that will have the Libreboard installed. Because as soon as you do heat reuse, right, you're gonna need to use some kind of temperature sensor. You need some kind of understanding of what am I heating up and how hot is it. And none of the control boards can do this. And so that's where the Libreboard is gonna come in. And so yeah, I can really imagine. I mean, I've always said I'm not gonna stop until every house in the US or in the world has a Bitcoin miner in it that heats the house. And even in warm climates, right, you still have water heaters. You still have other cases where you need heat, and Bitcoin mining just makes a lot of sense also there. And so that's where I really see the Libreboard going, is that maybe in a couple of years, you will basically walk into a Walmart or a Bauhaus or whatever your local hardware store is, and there will be a water heater that has a Libreboard in it because it's actually a Bitcoin miner. And you might not even know that it's a Bitcoin miner, depending on how this works. Like I could really imagine a future where you basically walk into one of these hardware stores and you need a water heater, and there's a water heater that costs a tenth of the price, right? A regular water heater right now, at least in the US, costs like $800. So imagine you have one for $100. You take that one, you go home, you install it, or you have a plumber install it, and all you connected is to Wi-Fi, and that's it, right? And you don't really know why it was $100, but that was it. But the company behind that sold it to you actually installed a Bitcoin miner in it, again with a Libre board and a couple of hash boards. Could be S19 hash boards, could be a brand new hash boards, whatever, and uses Mujina. But the actual mining, like the rewards for the mining, doesn't go to you as the house owner, but it goes to the company back. And they will make a lot more than the $700 that they basically upfront paid to you, because with the mining, right, as we know, there is a possibility, and with the price appreciation and all that stuff. So that's where I really see the future going, is that you will have purpose-built hardware that you can buy with a regular from a company. You can call them a plumber or whatever, or like a desktop version, right? Maybe a Bitaxe that is a lot bigger, that maybe makes, let's say, 500 watts instead of just 15 watts. And all of these need some kind of control board, and the Libre board is going to be in there, including obviously Mujina and all the stuff that we have built in OSMU already.
This is just such a fantastic lookout. Before we do close up everything else, we do have one question from developer Agro in the chat. He was asking, how will we be able to handle or tune mixed boards with different frequencies and ASIC voltages? Let's say Bitmain and miner hash boards and other miner hash boards. You briefly touched on that, but do you want to elaborate a little bit further into that?
Yes, no, I can. So yes, I have to say, right, we haven't fully tested this yet. It's just an assumption of us. But it's definitely possible to run different Bitmain hash boards together. So let's say if you have an S19J and an S19K, because basically each of them, right, have their own ribbon cable. And so through each of the communication channels, you can basically talk individually to these to the hash boards. So in each of the hash boards, you could send different frequencies and things like that, because the frequency is always set based on each of the hash boards, and they have their own controller. With the voltages, it really depends how you build your miner. If you look at an S19J Pro, for example, there's only one PSU or power supply, and the power supply has talks to the control board. So the control board actually tells the power supply if it should be, I think it goes between 11 and 15 volts. And that will set the voltages of the chips itself. So if you would, for example, connect all the different, if you would have only one power supply and you have 3 completely different hash boards, yes, you will not have full flexibility of the voltages of the ASICs. However, with Mujina and also the Libreboard, you could have an individual power supply for each of the hash boards. So that you could have different voltages for each of the hash boards. That's totally possible. That's completely impossible with the current system, right? With stock or the open source firmware, because Bitmain decided there's going to be one power supply for all the hash boards, and that's why the hash boards need to be the same. However, now that we have for our own hardware and software, you could basically do literally whatever you want. But yes, be aware that the power supply or the hardware that you give this system is going to be important. And that's actually one of the things that we're saying, right? We are going to need to do a lot of testing. I have at my home, currently I'm testing S19Js and Ks together, just to understand, right, what is actually possible of mix and matching and things like that. But I totally see the future, and we've seen this, right, in smartphones already, interestingly. Smartphone CPUs today, they actually have efficiency and power cores. So for the regular stuff that you do on your phone, the daily browsing, right, they only run the efficiency cores. However, if you want a game or video editing or whatever, then suddenly the power cores come in. They use a lot more power, but you also want to give it. And that's one of the things I could imagine, is that you basically have a miner that has, let's say, 4 hash boards in it, and there are 2 of them are very older ones that are very cheap, but they don't use a lot of power, and you can just run them maybe in even underpowered or underclocked, so that they're very, very efficient. And then you maybe have super power efficient or super energy efficient ones. These are maybe newer hash boards that you only use in specific times, or vice versa. Like, there's so much possibility that allows that to do. Yeah. So, and I see the second question. Sean, he's asking, does Mujina have chip tuning capability right now? No, it does not. However, it does understand how the current, like the protocol on how to change the tuning or how to change the frequency of the chips. It does understand, because right now it basically, like a stock firmware, just sends it, hey, all chips please run on this frequency. So I haven't done it myself, and that's actually literally something that I'm currently working on. I'm pretty sure if you would take Mujina and you go to an AI and it tells you, hey, can you figure out chip tuning, and maybe give it access to some of the logs, like how LuxOS does the chip tuning, it will probably figure it out in half an hour. So I don't think this is going to be really the hard one. It's just nobody has done it yet. So, but it will totally be possible. Like, so all the things that you see on LuxOS or Brains, like all these tuning stuff, Mujina will fully support them, because it's just software. And right, with AI, we're now so good at building all of this.
All right, thank you very much for sharing all of this. I'd say that's a lot of information that we received today from you, and I'm really happy that you made it out here and shared all of that with us. Is there anything else you want to leave with everybody here in the audience?
Yeah, so people always ask me, where can I get one? I'm like, unfortunately right now, right, there is only 2 of them. I have one, Ryan has one. And so I'm currently working on revision 3. There are a couple of issues, like I mentioned, the USB issues. I think there's also an issue with the Ethernet port. I'm still going to have to do some more testing there. So please don't, or if you really want to, you can. Obviously, it does work, but I would really suggest, if you want to build your own, wait for revision 3. I hope I will have this in, like, that's basically all of July that I'm doing, is finishing all of this to have a fully revision 3. I will then test it myself. I will produce one. Yes, and then hopefully with revision 3, that's basically the go that anybody that wants to produce this. So any of the Bitaxe producers out there, that's your time. It's a regular PCB. It's 6 layers. It doesn't have anything super complex on it. So that's then where we're probably going to be able to do this. It would be really cool to maybe like also have like a dev run. So if any of the Bitaxe producers is interested in helping, reach out to me. I would love to do like a short run that we can give to the OSMU community for testing. Again, you can test it with a Bitaxe raw or with an edit board, with any of the regular hash boards. Yeah, and from that, hopefully we're going to have a marketplace. So as with the Bitaxe, multiple manufacturers in the world that produce the Libreboards, the Bitcranes, the Bitaxes, and that will then really unlock the thing. So that's definitely something. And the other thing is, yeah, look at it and tell me, does it actually have all the capabilities on it, right? I spent a big part of actually building the Libreboard was just talking to different people and trying to understand what their use case is. And that's why I added all these different connectors to it. But if you have a specific use case that is not covered right now, please tell me about it, because there's still capability, right? I'm not saying we're going to change everything for revision 3, but if you maybe have a use case that is not covered right now, let me know, and maybe we can still add it to revision 3. So now is the time to tell me before we basically bake the revision 3 in it. And that's really it. If you want to follow along, check out, there is a website about the Libreboard itself, which will have a lot more information. That's the other thing that I'm doing, is talking about is all the documentation. So there will be a full documentation for the Libreboard as it is standard for hardware. So you can follow along there. You can follow along on the GitHub repository, or basically my Twitter account, where I'm probably going to post new versions of it. And really, that's it. So yeah, thanks for listening. Thanks for all the questions. Super exciting. And yeah, let me know if you want to know more.
All right, I thank you very much for coming in here today, and I'd thank everybody else in the audience for tuning in today. I'd say that's it for today, and hopefully see you guys again in 2 weeks for the next town hall. Cheers. Thank you, Schnitzel.
You're welcome. Thanks. Bye-bye.